Ah, thank you. Can you hear me now? Man, this happened last time too. I swear Streamlabs is out to get me or something. But I hope you guys are all doing all right. Hilbert Curve, Voxer Riffs, thank you for letting me know. Still Tree, Langors, and now you can hear. Okay, good. But yeah, I'm doing all right. I hope you guys are all doing all right. I was just saying that the viewers all jump up at the same time. It's like it'll be 1 and then it's 7 at once. And so I'm like, did you guys all get here at the same time, or does Twitch just like mess up for some reason? But we'll leave this playing in the background. If it gets too loud or obnoxious, just let me know and we can turn it off. But right now, we're not playing Blade and Sorcery, but I do want to do that eventually. Right now, what we're going to be doing is working on order independent transparency. So if I open this up, this is something I was debugging quite late last night. This is also kind of weird. I don't know if you guys can see that jitter. You probably can because it's really obvious. No idea why it's jittering like this. Just kind of weird. But what you can see is 2 transparent cubes, rectangles, prisms. I don't know. Yes, it's visible. Okay, yeah. It's weird. I'm not sure why it's doing that. It shouldn't. The code is just this. So like we are just using the orientation and then incrementing using delta time. So it should be smooth. Very weird, but I didn't bother with it because I really don't care. But anyways, because if we like play the actual animations are fine and stuff. So, you know, no big deal there. The cube isn't showing up though, so that's interesting. We'll have to fix that. Anyways, though, what you can tell is these are semi-transparent, but there's a problem. You can't see the back faces. So what we should be seeing, and we can make it more obvious by removing one of those cubes if we go into the render. This is just me messing around. I'm trying to get it working and stuff. So we'll go through a few different debugging things today that I have in mind, and we'll see if we can figure this out. But if we go to the render to frame buffer, which is what I've called it, and we just remove that second cube, what we'll notice is you can only really see one of these. Sorry, I am checking my phone real quickly. I have a friend texting me who wants to stop into the stream, so he may or may not show up. Okay, so what we can see here, sorry about that, is that we have this rectangular prism, and what I expect to happen and what I want to happen is you should see like it darkened when it hits the back face, right? Because that's what makes sense. Like we hit the front face, then we hit the back face, and it doubles up on that transparency. But we're not seeing that, and it's really weird because if I do this, this is all in the same draw call, and it is working for different colors, yet it's not working for the same color, which is why it's so strange. Like you can see that we are getting that kind of mixed colors for the blending where they mix together. That jittering is getting me really obnoxious. So let's go ahead and turn that off for now. So that's what's kind of weird for me, is why would it work for 2 cubes, but it's not working for 1? And so the first thing I plan on doing is trying to fix that. And if you're not aware, order independent transparency is basically just a way of rendering blending and stuff through multiple different objects and maintaining, not having to like sort your draw calls and stuff. So it's a pretty useful technique, and I'll show you guys the sources that I'm using and stuff to follow to get this working. But yeah, if we go up to here, I have been following this article to kind of get it working, and he's basically following this paper down at the bottom here. These are just some examples of how it should look, and this is really nice too because they show us some examples of the accumulation buffer and the revealage buffer. And I know I already have problems immediately because if we look at render doc, this is my accumulation buffer. So this is my revealage buffer. This is my accumulation buffer. Oh, and actually we don't have problems. I thought we weren't getting color, but we are getting color here. So it's kind of working. And if we look back here at one of the examples that's more similar to ours, you can see that I kind of get the same thing here inside of my, render doc. Inside of here, this is the accumulation. looks somewhat similar to this. We got the black background in that, but the revealage is where it's wrong. So if we go look at the revealage, we should be getting a doubled up look here where it's hitting the front of the cube face and then the back of the cube face. And we can see that kind of in here where like this progressively gets darker as more faces intersect with each other. And you can see it a little bit better here with the glass. How the glass, you can see when it goes through and it hits multiple surfaces, it adds up. And that's what we want. We want additive blending, and that's what should be happening. And that's why it's kind of annoying that it's not. So I've been working quite a bit, and it's just weird. So how does this all work? Well, the way it works is if we go down here, back to where we were, I have this thing which is a render for our draw list 3D. First we upload the vertices, then we go over to here, enable different draw buffers. So this is the accumulation buffer, this is the revealage buffer, and basically what these are is accumulation is like you just keep adding up all the colors and blending as you go, and then the revealage is like how much does this impact the final color in the actual world. Because then what you have to do is you have to do a final blending step where you blend all those blended colors with your actual geometry in the scene. That's opaque. I think, yeah, opaque. And you have to blend that stuff. And so that's what this final color is for. And this is just a float, whereas this is like a Vec4. If we look at the shader, we can see that too. Where basically the accumulation is a Vec4 and revealage is a float. Voxers. Well, that doesn't make any sense, actually. You're always passing through the cube twice unless you have multiple cubes. So their revealage should be the same, should it not? Voxers, I think you are right. That makes a lot of sense. Well, okay, if you're looking at it from an angle, though, let's draw this out real quickly. Because if you're... Whoops, that is the wrong thing. Let's go over to drawing screen, if I can get this up and running. Here we go. So if we're looking at it from an angle, though, say we have a cube, and especially if it's like a rectangular prism and it's not just a cube, which is what I have there, we should be able to see portions where if I'm looking at it from this angle, right, if I see this, that's hitting less surfaces than if I see like this point. Or no, I guess, so this would hit two surfaces, right? This would hit two surfaces. This would hit two surfaces. Yeah, cube is convex. You were right. Vox riffs, you are right. So if we had a shape like this, then we would hit 1, 2, 3, 4 surfaces, whereas down here we would hit 1, 2 surfaces. Dan. Okay, so you are completely right. I can't believe I did not think of this. Thank you. This is why I stream. So maybe this is all working out perfectly fine, and I wasted a lot of time last night debugging something that wasn't actually an issue. Okay, well, we can test this too really easily. Let's make like a cup, which is just a cube with like the inside kind of hollowed out, I guess, and we'll try that out and see if it looks correct. Which I believe it should, because it looks correct with this. I would say that cube just really needs some I would say that cube just really needs some lighting, really. Yeah, that is true too. Which we can do eventually. I can't believe I didn't think of that. Yeah, that makes a lot of sense. What we'll do instead of having like a hollowed out cube is I'll just draw an extra cube inside of that cube, and it's not a cube, it's a rectangular prism. I keep saying that, but yeah. Yeah, if you imagine the rectangle continuously deforming to something like a parallelepiped, gradually the rectangle would become two faces. Yeah. Yeah, I can't believe I didn't think of that. Thank you. I was pulling my hair out last night because I'm like, this does not look right, but it does, and you guys are completely correct. There's nothing wrong with this. So I had it working right this whole time, and I'm like sitting there trying to fix it and stuff. Okay, so what I'm doing is I'm making it the same color. Let's make this cube the same dimensions too. So we're gonna go ahead and do this, and then I'm gonna draw this slightly above this one. So, and actually I'm gonna decrease those dimensions slightly. So if we do this, and then we're going to move it up on the y-axis 0.5. And then we'll take this down 0.2 in all the dimensions. Well, except for the y dimension. Well, the y dimension will take down 0.5. Now I'm not even going to attempt to do math this early in the morning. So we'll do this. And now if we draw this again. Okay, so the color most definitely doubles up there. Trying to tell, does that look right? I guess that does look right. Especially if we look at something like this. Yeah, let's actually set this up too. We'll do 3 cubes kind of like that, and we'll see if that looks correct as well. But yeah, it would get brighter as it does that. I guess that does look right. Yeah, man, well, that makes a lot more sense. Sorry if you heard that, Joe. I try not to drink too close to the microphone, but sometimes I forget that I'm right next to a microphone. Okay. Yeah, I guess I was expecting something like those glasses, which was kind of stupid because they have like a lip and then they have another lip, which means it's going to be a completely different kind of completely different geometry. Man, that's aggravating. So I feel like there's still a little something. No, yeah, okay, so if we look at these chess pieces, yep, they are one solid color except for where you have those bevels. Yeah, that makes complete sense. Man, I am an idiot. I spent so much time on this. 15-minute stream OIT debugging? Yep, we're done now, guys. They also seem to take into account the lighting. Yes, and that is one of the things that they mentioned too, is inside the transparency shader, they actually have this pre-multiplied reflect, which is basically like the lighting and everything applied to it. So I believe if this was like a deferred renderer or something, this is where you would like apply all that lighting stuff and whatnot and then do all that. We can do that eventually. Not saying we can't, that's fine. I do want to test this too, just make sure that this is right. So they give us the color values here too, and I think he had a note down here. Note that this reference image fixed a typo. The alpha values are 0.75, not 0.25 as originally reported, and are given before computing the pre-multiplied. So the blue square is 0.75, 0.75 in pre-multiplied alpha, and 1.75 with unmultiplied color. So this is what we want, is one. Okay, yeah. So we'll set up these colors and just make sure that we have the same kind of reference. And if we do, then I am satisfied and we can move on from this. So let's do a couple of cubes. Let me actually just move that back to where it was. Okay, so that's good. And then I'll kind of shift them because that was a good shift, I think. And then what we'll do also is we will just make sure that these are the same size. They are the same size. Cool. And then what did he say? Those were 0, 0, 1.75. So this one will make 0, 0, 1.75. This next one, I believe, is just, yeah, 110.75 and then 100. Okay, so 1, 1, 0.75, and then this one would be 1, 0, 0, and 0.75. And then this one, we will move back kind of the same shift. So that would be 1, or I guess -1. And then another -0.8 would be 1.6. And that should give us something similar. So we'll see if it looks proper or not, which... Okay, well, it's a good thing we did this because that's definitely not right. I have them in the wrong order. But that's still very wrong. So we should be getting something like this. Instead, we're getting something like that. Yeah, definitely wrong. I wonder why it's wrong though. First of all, let me swap because I think I have them reversed the way they do there. Yeah. So let's do that first and just make sure that's right. So we'll just switch these to positives. Positive. I wonder if it's because they're like intersecting too. Technically, like these cubes aren't necessarily like, no, they shouldn't be intersecting, these cubes. Okay, let's shift them again the other direction. I think if we do the Z direction, negative, that should shift them to the left. If not, it might be the X. I'm not sure. Okay, it's definitely the X in that case. Let's do that, see if that works. Nope, that did the same thing. Okay, well this is good enough. I mean, this should still be the same as what they had technically. I guess what I could do, we'll rotate the camera the opposite direction instead of that way. So let's go up here. And we'll go negative 45 instead of positive 45. And that should rotate it so that it's facing like the correct direction. Or it'll rotate us so we're not looking at all. But that's just because we have to fix this so that we're positioned correctly too. Okay, so if we do this, what does it look like? No, I guess I rotated the wrong way again. So let's go to 135 then, maybe? And let's just change this to that, and we'll do that, and then I will just move this down and move that down, change that, and that should be fine. Okay. That way we only have to change that. And actually this should be negative of that. Okay. Let's see what we get this time. This should be the easy part. I guess 90 degrees. If you're doing additive or something, that would be twice the brightness. Yeah, it is doing additive, but that's like the way that it should be working. We'll take a look at the article and stuff too in a minute. So basically what's happening is the color should be adding up, but then we use this weighting function that should kind of balance it all out. Okay, here we go. So this is exactly what we want. This is pretty close. We just have the camera oriented slightly differently, but we should still be getting something similar to this. So yeah, okay, so let's take a look at what's happening again. So basically the transparent shader, what it does is we have the accumulation and we have this thing called the reveal edge. And actually, let's just try this real quick. I wonder if it's that thing. I'll talk about that in a minute if this does work, but... Oh, and it looks like that might have worked. So if that did work, we'll talk about what happened there. Okay, so this should be like a kind of greenish color. Does that look correct? Kind of greenish, and then kind of purplish, and then kind of orangish. Greenish, purplish, orangish. Yeah, I think that looks right. And then we get yellow up there, and we get red back there. Okay, I think that looks right. Yeah? I don't know, you guys concur? If you don't, then it doesn't look right. But basically what this thing was, this was something special for coverage. And this came from the paper. Yeah, okay, so this came from the paper. I think this was something like a material kind of transmission type thing. If we look at the actual paper, if we pull that up real quickly, we can kind of go to that and just see what they were talking about there. I believe, nope, that's not the paper. One of these things are, let's see. I had it open earlier too, and I closed it for some reason, but let's see. Oh, actually, he has it linked right here. I don't know what I'm doing. If we just grab this, or maybe that, paste that. Nope. Yep, that link was broken. I forgot about that. Okay, which one is it? Not that one either. I'm like 90% sure I found the paper. Maybe I didn't. I don't know. Okay. Presentation slides. Okay, here, the original paper. There we go. Okay, that does work. Cool. So if we look down here, we can kind of see what they were talking about with that portion. Down here is where they get like the final derivation. I don't know. Okay, so right here is where they have that whole weighting function. So basically they're saying multiply the color by the weight, which we're doing here. We calculate the final weight using a couple of intermediate values, and then we get the accumulation by doing the color times that weight. And then the transparency is just the alpha, or the revealage is what they're doing there. And if we look up, they actually write out their equation here. Okay, and so what we can see is this is alpha times max of all this stuff, which is basically what we have. They have a few different variations of this equation because certain ones work better for different scenes. And then they just say, okay, d of z is just glfragcore.z. And if we look down here, okay, yeah. So listing 3 gives an implementation both of our new blending methods where the revealage as opposed to coverage tracks all that. So we assume partial coverage transparency where the background intensity isn't attenuated. Okay, so they're just talking about how they use different, maybe it's down here. I remember reading something. Maybe I didn't. Maybe I'm going crazy in that line of code I added for no reason. But, yeah. Okay. Not quite sure. If you want, you can read through this paper. I'll post this in here for you guys who are interested. Actually, I'll post the original article in here because it's a little bit easier to get through and it has a link to the paper. So if you're interested and you want to learn more about that, that's good. But I think this is working pretty good. Let's do the rotation again and just make sure that's working all right. So if we add this back in, let's just make sure that's still okay. And ideally, I'd like to figure out why it's doing this weird jittering, because that should not happen. It's just very strange. But yeah, okay, as it rotates, we can kind of see we get correctly blended colors throughout. Let's add global illumination next, which Voxerus was pointing out a lighting system would be very nice. And we also have to get this working, because right here, there is a cube that should be showing, a 3D cube, but it's not. And so I'd like to see why that cube is not showing up. Okay, so let's fix that jitter first. It should be pretty easy. So we say the position is the orientation out. Oh, I am stupid. Once again, I'm a frame off. I think that's it. That was it. Man, guys, that is what one frame of difference makes, okay? If you're lagging by one frame, it can be very visible and very annoying. Wow. Well, that was easy. Yeah. I've noticed that in other places too, where like if you're dragging something, before I had a bug where like when you were dragging these, it was a frame off, and that really messes with you because it looks like it's lagging behind, which it is. But yeah, those can be pretty bad. Moral of the story, don't program late at night. I guess so, right? I had a feeling it was that too last night because I kept switching it around. I was like, okay, maybe if I move all this, except I was moving all of this like down here, and I was like, nah, that doesn't work. And I just kept moving it around and was like, I'll figure it out in the morning. Or if you do, just have some coffee. That'll probably help. Okay, so that works out pretty good. Now, let's add global illumination. And I'm still thinking of what the best way to do 3D objects would be. So let's talk about the render. I'm taking a different approach, strongly taken from IamGUI and how IamGUI works and stuff. I've still got a ways to go with the actual render and everything. I've created like this simple vector thing, which is just like a simple vector, and not a vector as in like a position, but a vector as in like a list in C++. I should probably call it a simple list. But anyways, the approach I'm taking is kind of like IamGUI, where we basically have our vertices, we have our indices, we have our draw commands, we have our texture ID stack. And the draw commands, just texture ID, vertex offset, index offset, right? So these things are basically just like, this is where the draw command starts, and then this is how many elements are in the draw command. I don't actually have a lot of this implemented yet, but the reason for setting it up this way is, one, it's pretty simple. So this is like fairly straightforward. We just allocate a VAO, VBO, and then we loop through these draw commands. We allocate enough memory for each of those vertices, and then we can just draw these. And the whole idea with the texture stack is you only ever have one texture per draw call batch, which may not sound great, but that is a little bit better. And then what we can do is we can eventually like combine all those draw commands, so it's technically one draw call with like GL multi-draw. And then we just pass it like the draw commands here. And so then we still get away with one draw call, even though there's many things in there. So yeah. And Voxerus, why is a list called a vector in the first place in CPP/STM? I have no idea. That confused me a lot when I was coming from Java to C++. I was like, what the heck? Because they do have a list too. Like, you can include list, and you can say stood list if I... But this is a bad list. Don't use this. Because what this is going to do is that's going to be a singly linked list. That's what I believe this is. And so then it ends up being super slow. Yeah, linked list. And I don't know why they did that. Very stupid in my opinion. They should have called it singly linked list, and then doubly linked list, and then list, which is, you know, what you expect. Or dynamic array or something, but vector makes no sense. I have no idea why they thought that made sense in 2000. But yeah, the list is a linked, yep, linked list. Okay, so yeah, we've got like this whole idea. And so what I was gonna say with 3D lines are a little bit different, and they're not working too. So they were working until I started doing that stuff. So we're gonna have to see why they're no longer working again, which I think I already know, but yeah. Langors, Java also has a vector class that's also similar to the list. Huh. Makes sense. So with the draw list 3D, sorry, I think I kind of want to do this a little bit differently, because you have the tendency with 3D objects to get very large, and you know, what if in the future I want to support importing like arbitrary 3D models, and you don't want to have to like handwrite models and stuff and all this, and you want to add textures, right? You want to add like one texture that gets mapped to it and everything. And so in that case, like, this concept doesn't really make much sense for a 3D world. Instead, what we should have is like some sort of models, right? And we would have like a simple vector of models. Maybe not model ID. Yeah, like maybe something like that. And then like a vector of, I don't know, GLM mat4s or something, transforms. Like something like this makes more sense in 3D, right? And I'm trying to think of exactly how this would work and stuff too. For now though, this works fine. It's gonna break in the future if I ever want to do anything more complex, but yeah. We can move on to lighting and stuff though, and then just kind of work with what we got, yeah. Okay, so, for this, what we can do, so we bind the frame buffer. I think what's happening too is I just messed some stuff up in here. So let's go ahead and I'm gonna remove these and remove this, and we're gonna see if it still works. I might have to remove one more in the application, which I believe this should still work. Okay, no, it does not still work. I think I have one more in here, and that's why. Let's see. No? Do I not? No? Well, okay, I think this might... No, that does not either. Okay, so those are important. I guess those are important because it broke stuff. So if we go back into the render, which I lost, there it is. Okay. If we go back into here, what this is this is just me enabling like which specific buffer or frame buffer attachments I want to draw to. So the way that this works, if we look in render doc, is I've actually got a frame buffer with 3 attachments. So these are the second or first. So if you have 3 attachments, 0, 1, 2. This is attachment 1, this is attachment 2. And if we do the final draw raise, this is attachment 0, and you can see it says FB2 is unused, and it's not showing FB0. I mean FB1, but that is unused as well. And we can look here, it's using these as inputs to this. And so basically what I have to do in order to make sure that it doesn't overwrite the different frame buffers is you have to do something like this, where you basically say, oh, that's the clear, wait. Okay, maybe I'm not. Okay, so let's see, if I comment that out, actually, I might have just done the wrong thing. So we do need these. These are just clearing the clear color. That's not what I thought it was. I thought this was this stuff, which is basically saying just draw to those attachments, but I don't think we actually need that. And that's what I was trying to figure out. Okay, no, it looks like we do. So if we don't have those, we get this weird thing, which is what I was kind of debugging the other day. And another weird thing is like if you do this through RenderDoc makes it look like it's all working perfectly fine. And so what I believe is happening is like, since these are all part of the same frame buffer, I think if you don't explicitly say, hey, these are the ones I'm drawing to, I think it's like trying to clear the second 2 attachments at the same time that it's using them. And so it's messing with it and just doing all sorts of weird stuff. And so you're getting that weird glitched stuff, which is why I think we have to do this. But in order to do this, we have to say render to frame buffer. We also have to say that up here, where we basically go and say these are our draw buffers when we're rendering our regular stuff, and that should make it so we actually see the other 3D stuff that I was trying to draw. So now if we go back over here, no, okay, we still are not seeing the 3D cube, which is a problem. Why are we not seeing that? So that should go down to here. Is it because I have... So depth test is enabled. It might be a state thing. Let's go down here. So this is where I do this stuff. I wonder if it's because it's culling faces. Let's do disable cull face and see if that fixes this. And do we get our lines back? So basically, I should be seeing a 3D cube there, but I'm not. Yeah, still not seeing that. Which is strange, to say the least. What if we just disable the depth test? What does that do? Okay, so that draws it again, which is weird. We shouldn't have to worry about the depth test to draw that, unless I'm just not clearing the depth buffer. I think that's what it is. Okay, so let's re-enable that, turn that back off, and I think what's happening is I'm just not clearing Yes, I think that's exactly what's happening. So if we go into application, I have this main frame buffer clear color attachment, but I don't actually clear depth stencil. We should probably do that. And I will add that function very quickly. So framebuffer.h. Let's go into here and we will have a void clear depth stencil. And it's also funny, you can mark these as const in C++, but really you're actually changing the frame buffer on the GPU. So it's not technically const, but we can mark it as const. Okay, so if we do that, can we say GL clear depth? Okay. No, that's not quite what I want to do. Let's see. I want to clear the depth buffer for a specific. Actually, I should be able to just bind it. If it's already bound, I'll just assume it's already bound by this point. We should be able to just say clear GL depth or GL stencil. And that should just clear it as long as it's bound, which at this point it is. Should work. So let's see if that fixes our problem. And if it does, I think we're basically, nope. Okay. I am using that wrong. What is it? I think it's depth buffer bit and stencil buffer bit is what I want, not just that. GL depth buffer bit, yeah. GL stencil buffer bit. Okay. So if we do that, that should clear it properly. And now if we go here, there we go. Okay, so we're seeing that, and this is another problem that I was hoping to solve. I don't know, is it correctly rendering these over that 3D cube? I think it might be. Well, so we're getting some weird stuff going on, right? It doesn't look like it's depth testing these fragments properly, because if it was, then it should be discarding the fragments that are behind the lines, which is not happening. And this is what I was afraid of was gonna happen. So that's the next thing we gotta fix, because I don't want that. That's gotta work properly. Let's go back into the render. Okay, so if we go down here, we should still be doing depth tests when we're rendering the 3D transparency stuff. Let me just look at chat real quick. Code should be self-documented. Yes. Usually it isn't though. Yeah, going through the yellow but not through the red or the blue. That's what, yeah. Is your timeline editor fully custom or some sort of library? Fully custom. I mean, I'm using IMGUI, but the drawing and the manipulation and all that stuff is, I had to hand code, which was kind of annoying. But it wasn't that bad. Question completely unrelated to what's going on in Gabe's stream, but does anyone know how to import a Python module from a file like object, not the path? I am not good at Python, so I'm not going to try and answer that. Okay, so what's going on here, though? We should still be testing the depth function. So maybe I have to say GL enable GL depth test. Maybe the depth test isn't going on. Let's try this. Because basically I'm just saying don't write to the depth buffer, but read from it. No, that doesn't. Yeah, that's not working still. So basically we have the depth test. We have the depth mask set to false, which what this does is this says disable writing to the depth buffer, but it should still read and discard fragments if they fail the depth test. Oh, and then I have the depth func as always. We don't want that as always because that says always pass the depth test. Okay, that makes sense. Let's try this. And actually I might need that, and then we might need to disable. Okay, so we're getting closer there. Is that working? Yeah, I think that's actually just working. I'm trying to look at it. Let's slow down the rotation a little bit, but I think we got that. That was way easier than I thought it was going to be. I need to do this in my Minecraft clone soon too, because I have this broken there as well. Okay, so let's just make sure we're setting up all the state correctly. So disable writing, we enable the depth test, we disable coal face, and then we enable blending. We set up the blend functions for this order transparent stuff. Down here we say the depth mask back to true, so we enable writing to the depth buffer again, we enable coal face again. We set the depth func to less, which we don't need to do that anymore since I have fixed that. Okay, cool. So I think that's pretty much it. So that was easier than I thought it would be. Hopefully I'll be saying that a lot this stream, but yeah. Yeah, I'm trying to see, like, it looks kind of weird going through the shapes like that. But that looks right. That is how it should be. Cool, so now we can finally do what I wanted to do from the beginning. So the whole reason we're doing this is because I wanted to be able to fill this cube in, which clearly we cannot do. Well, I guess not so clear, but we can't do that with the way that it is right now. Let me move this over too so that you guys can actually see the full timeline. That would be helpful. Yeah, okay. So this is what the timeline looks like too. We have this whole thing where I can drop these down for different tracks. I can also right click them, add tracks above or below. So like I can do that, delete that track. I can also add an audio source. So let's pause the music real quick. Not that. Let's go over here, pause that. So we can add an audio source, which you'll see it pause the whole thing, which I'm fine with because if you're, selecting an audio source, it shouldn't matter. And so what that does is now we can hear, or hopefully you guys can hear that. So basically now we have this audio source. We can scroll around in here, right? It still works. And I believe it should, let's add a track. If we, I can't drag between tracks. So that's something else that I've got to add is like being able to drag stuff between tracks and everything. But if we drag this down here, yeah, you'll see that goes behind it, but I still do have problems. Like you can see, I can still move it even though I'm clicking on the audio source there. Okay, cool, you can hear it. And then I also added the zooming. And so you'll notice like this kind of loads in. And that was a very necessary thing to do because if we don't do that, then it basically stops the whole game because loading all that audio takes upwards of 66 milliseconds when you're loading the whole audio source in. And so what I did was I basically split it up, said, okay, load that audio waveform in over several different frames and just cache it, which means that we get a smooth 60 FPS. You can like see up here, it doesn't affect this at all because it's not slowing it down. If we were to turn that off, it like lags horribly. But yeah, I've got that. This resets the zoom, or it should reset the zoom to the base. Oh yeah, it did. Okay, cool. So that resets the zoom, and then you can turn on the magnet, which if we turn on the magnet, you'll notice it snaps back and forth here. So we can like go here and then it snaps there. It also snaps to the cursor. So if I go over here, we can snap to the cursor. So you can line up the cursor. Like I want this to start exactly at 1:30, which is 1.5 seconds. Now it starts at 1.5 seconds. We've got it lined up. Or you can line it up to the audio in here somewhere, and then we can say, okay, now I want this to start at that point in the audio, whatever, blah, blah, blah. And then if you switch the audio source, so if you just hit add audio source again, and we were to change it to something like this, which is for the next video. Okay, yeah. So if we were to do that, then
most 3D game.
Yeah, so that's me. And you can see the audio here. It looks like it didn't recache that audio though. Okay, there we go. So now if I do that, it fixes it. So that's a bug that I've got to fix at some point. So it didn't realize that the audio had changed, but it doesn't hold on to the old audio. It drops that and then adds this so you don't like get memory leaks or anything like that. And it all just kind of works out, which is good. And yes, the magnet is new. That wasn't actually as hard as I thought it would be. The zooming was the part that I thought would be hard, but it's actually easier. You'll notice the time segments up here don't scale very well. Like they kind of just, I don't know. It's not that bad, but yeah. I think it would be better if they like stayed aligned to like second fragments and second, whatever. I don't know. I'm fine with the way it is now. But yeah, this is pretty good. It's turning into a full editor, which is nice. And you can do some cool stuff with it. I've also added, it's been a while since we've streamed, so I'll show you guys the different things that are in here now. So I have also added, like if we were to add a circle here, and we were to add a create, or I guess let's do a move to. So first of all, where's the circle? The circle is behind all the 3D stuff. So I guess this is another thing. Or no, that's a square. The circle's behind the square, but the square is behind the 3D stuff too. Should the 3D stuff be behind the 2D stuff? I guess we can eventually like change that behavior and stuff, which is something we might want to do. I also have to get snapping between tracks here because it would be nice if this snapped as well, but that's all sorts of other stuff. Okay, so anyways, you can kind of see the circle back there. Let's turn off these things so that we can actually see what we're doing. And if we go into here, so we got a circle, we can go up here, we can change a bunch of different stuff, right? We can change the stroke color to red. I actually have to add a stroke width to get that in there. So we got stroke color, you know, you can change the fill color, all that stuff. That's all great. And then you can also, if we move this up, you can do different kinds of easing for the different animation types and stuff. Oh, and that's a problem I got to fix too. It should not be doing that. So I'll have to look into that. But basically, if we have it say move to the bottom afterwards, so if I copy this, and you can see it's kind of a pain to use different portions of this. So that's something that I've got to fix, is make a lot of this easier to use. So right now what you can see is that the ease type is cubic and it's in out. So what that means is it'll just like slowly start and then slow into the end there. And let's just kind of increase that. But we can change this. So we can say, actually, I want to use a bounce easing function. And so if we do this and we say bounce out, then what you'll see is it goes linear and then it bounces out at the end there for the animation, which is pretty cool. So there's not actually any stuff going on there that's special. It's just doing a different kind of easing function, and we can change that to one of these. You got linear, sine, quad, cubic, exponential. So exponential is a little bit faster. Maybe I'll have it so that one of these times, and that was just out. So you can also change it to in out, all that stuff too. So it's pretty cool. I am happy with the way that turned out. And I think that's like one of the last things I've added. And if we delete this, it should delete everything. And we can go back to here and it just kind of works. Okay, so let's add a fill color for this cube, at least, so we can get that done too. The 3D lines too are something that I had to hand code. And so I still need to add Bezier curves to that stuff and everything as well. Yeah. SE Woods, that's a neat piece of software. Was it self-composed? The music was not self-composed. That was Mario, if that's what you were talking about earlier. But the software itself was all created by hand, yes. Harry Studios, don't tell me you made your own animation editor. I did. So not made, it's not complete, but it is in progress. Almost complete enough to where I can start making it, using it to make actual videos and stuff. If we do the create too, this should, yeah, so that creates that cube and everything, which is nice. I think if we do uncreate, it should just work too, because it basically uses the same stuff as like regular SVG objects. Yeah, so uncreate works too. So that's pretty cool. But I want to add that fill color, which is what I've been saying, and we will actually do that now. Yes, referring to the music. Yeah, not hand composed for sure. But yeah, that's pretty cool. So just trying to think of other stuff. Okay, so I guess, and this is one thing that keeps happening. I have no idea what's going on here. I have lost the ability to click on segments. This has happened a couple of times. I'm not sure what does this. Like I can click on these, but I can't click on these. Yeah, I can still... Okay, actually, I think I might know what's happening. But yeah, I have that bug listed down. I've got to fix that eventually, because that shouldn't happen. I wonder if we... No, that doesn't fix it. Okay, so anyways, let's add a fill color to our cubes. So if we go to shapes.cpp, I think I have in here a cube somewhere. Yeah, okay, and so this is how we do the cube. I literally just do different contours. So this is kind of like the API I've written for 3D lines and stuff, right? It's very similar to NanoVG. I just say begin a contour 3D. And I say do a line to this, do a line to that, line to that. And I say close the contour. And I think you can pass in, no, you cannot pass in anything here. I think I have SVG close contour and close contour 3D. I thought I had something else here. So basically what this does is this actually like closes off the line segment too, I believe. If we go into here. Yeah, I think, no, okay, I thought this did, but I guess it doesn't. Okay, but anyways, what this does is it basically just creates a bunch of line segments, connects them all up, and that's why one of the things you'll notice is that since these are all part of one contour, if you look, the edges actually combine, and we can see that a little bit clearer, especially if I just like remove some of these. So let's do that, and let's go all the way down here. Okay, so let's comment all that out so we just have one face, and you'll notice that if you look at the corners are actually joined, which is very nice. So they actually join at the edges there. And you'll notice that at the end, it's got that little bit of a corner, and so what's happening there is it's not actually joining that last piece of this contour. So that is something that I should probably fix. And it's a little bit more apparent too, especially if I just like remove one of those lines. I'm not sure if that's going to leave it hanging off the edge, which is what I think should happen. No, okay, so it still does join. Okay, yeah. So close contour does still close the actual contour there. So then if I was to remove one more, what you would see happen here is it basically turns into a triangle. Yeah, because now it's just getting 3 lines, and then it just closes at that last line there. And VoxRiffs, thanks for showing up. All good. Harry Studios, have you seen Artificial's video where he showcases a similar tool that he programmed called Motion Canvas? I have, yes. And the one issue that I had with his is it's still code first. It's not visual first. This is like, which is fine. I get that. But that was my whole problem with Manum. Manum, if you ever look at it, is like, you just write a bunch of code, and that code turns into an animation editor. There's 2 big problems with that, in my opinion. One, it's not real time. Artificial fixes that. His looked like it was real time. But 2, most of this stuff is configuration stuff. Like, I don't want to have to code, create a text object, place the text object at the top, center it, do all this. Like, I should be able to just click here, and then what I'll have eventually is a gizmo that you can click, and then I can just drag it around, place it where I want. Have some snapping mechanisms, whatnot, all that. I feel like that's the best way to go about this. And then, because sometimes you do want to code something, I'll have an animation object up here, which is like a scriptable object. And then you can use Lua to write a script to do custom stuff, add extra objects, all that. So, yeah, basically, I feel like code first is the wrong approach for these. But who knows? I might change my mind after using this for a while and say code first is actually better. But I do definitely think visual first is probably the best way to go with this. But yeah, okay, so let's go back to that cube because we want to actually add some drawing for that. Okay, so when we render that cube, what do I do? Okay, when we render that cube, I think I just render it there. Okay, so if we go into the animation manager and we go to render, render, okay. So we go through, we call render on the object. Okay. trying to look for where I render the actual cubes, which is going to be somewhere down here. I think if we just do anim object v1 cube, and I'm also thinking of some other stuff that are going to affect this. Type. Nope. Anim object type v1 cube. Okay, so this is where we do it, and I can very easily now add some extra stuff here where we basically say render draw cube, I guess draw filled cube. No, draw I should have something in here. So we got all this stuff, all that stuff. Do I not have? Oh, no. Okay, I don't. I need to add an API for that, first of all. So let's go to render.h, which is right here. 3D stuff. Okay, cool. So 3D, let's call this 3D line stuff. Line. And then we'll go, actually, I'll copy that. We'll go down here. This will be 3D stuff. Okay. So we'll add an API for all this stuff. We can say draw cube. And I guess this is a filled cube. This will take in a vec3, const vec3 position, or I guess this is the center of the cube, and then a const vec3 size of the cube. Okay, and then if we go down into the render.cpp, we can go ahead. That was right below 3D line stuff, Bezier to 3D. What was that called? Wait a second. Okay. Bezier 3 to 3D. Okay. So we can put it right down here. Put that there, and then this will be 3D stuff. Okay. And all this is going to do is say draw list 3D dot add cube filled, position, which is the center, size, which is the size. Oh, and we of course need a color, which I can actually get using this. We can say color const, or I guess vec4 color equals get color. Okay, so that gets me a GLM vec4. Is that what I want? I want a vec4. So I have get color compressed, get stroke width. Okay, that should be fine. So we can say const glm vec4, and then we can just say vec4 color.r, color.g, color.b, and color.a. I really need to get rid of GLM because I'm using my own math library here and it gets annoying converting between this stuff. But anyways, that should be fine. So we basically have that. And now if we go back into here, we should be able to say render draw cube filled, or draw filled cube. And then we can give it the center, which is this position. And then we can give it the size, which is this as dot cube dot side length. And since this is a cube, we need to convert that to a vec3. Which I guess we would do this 3 times. And maybe we cache this just to make it a little bit easier to write all this out. Float side length equals that. And then we can say scope this out. That way that doesn't get leaked into the main scope. Okay, so then we can do this. Okay, so then we're going to draw that, but we want to give it a color too, so we can say render push color. And what I'll do is give it this fill color. Okay, and then we can say render pop color, and that should do what we want. So now if we go into here, when we render the cube, which should complete after this, we should see it. Okay, cool. So it's got a black color there. We can change that fill color though. Alpha is up there. That doesn't look right. Okay, so almost there. Let's see what's going on there. So fill color. Yeah, that looks right. So what happens here? So we push that color. Okay, so that makes sense. Color stack, color pointer. Oh, I think what's happening here is it's just not normalized. Yeah, I think that's what's happening. We just need to normalize that color. So what I can do is say push color this fill color over 255.0f, and that should do what we want. I think it's expecting a reference, so I might have to. No, it just doesn't like that division operator. So let's do times 1 over that, and we will do that. No, what's it saying? Oh, this is a U8 vec4. Okay, I see what's going on here. Okay. So let's create an override real quickly. So render push color. I don't think I have U8 vec4 here. No, I do not. Okay, so let's just do push color. Do that, and then we'll automatically convert it in here, which is what I thought was going on, but I guess not. Push color. Okay. Do that. We basically want to do something like this, except we're going to say normalized color equals that color.r over 255.0f, color.g, same thing. That and that. And then we do that, and we're going to push the normalized color there. And we're going to cast all of those to floats. That should take care of that. Okay, sorry, Harry Studios, fair point. But as a front-end developer, I do prefer having to code my visuals because every visual editor I've ever used just gets tedious to use as soon as you reach a certain threshold of complexity. Yeah, and I get that. This is very tedious in my opinion. I mean, like literally, so this is for, I think, my latest video that I was working on before I finally said, and also there was issues with Manum, which is why I switched away from this, but that's besides the point. I feel like this is just kind of tedious. I'm just setting up stuff here. I would much rather just like write, hey, this is what I'm writing, and then plop it in there. And then to edit anything, you have to like change this. I don't know. It's just, I get that. Maybe if, I don't know. Yeah. Different people, different opinions. How's it going, Sam? What about just normalize the vector where you convert it to your vector in the new functions? I like this better just because I don't have to normalize it. Like, because I use U8 vec4 in a lot of other places, so I like this better. Just do it automatically. If we do that, cool, we do get that. And I guess what we probably want to do is we have Z fighting going on there. So what we can do to fix that is we can just adjust the size very slightly. So if we go into, where was that? I think it was Animation Manager. Yes. Okay. So if we go here and then oh, this is the wrong place. Oh, it's in here. Okay, yeah. So if we go into here, and we just say it's this minus 0.01f, I think that should be good enough. Little guy, new to the stream. No, you're not. We've seen you here before. Hilbert Curve, welcome, little guy, to the stream. We're working on animations. I'm like 90% sure you've been here, little guy, or am I remembering you from Discord? Either way, sorry if that was offensive. I wasn't meaning to be like harsh there, but is the stream delayed or just the on-screen chat is delayed? On-screen chat is delayed, and I check it like every so often, so there's a chance that I may like take a minute before checking it and stuff. Looks like this was not good enough. I don't like having to do that much of a difference. Yeah, okay, so that's definitely not Z fighting anymore, but I don't like that. Why is that Z fighting happening? So if we do this again, yeah, it looks like this is happening where the triangles of these lines are connecting. I'm only watch Crumble streams because this is boring. Okay, that's fine. Yeah, I'm going to have to look into this. That's weird that we're having the Z fighting there. If you're curious too, the lines are being drawn using this shader, which does a lot to make sure that the lines actually work properly. I'm wondering, I think there's just floating point something or other going on here that's making it so that we don't actually get, or so that as the triangles join, they're not properly lining up there. Okay, well, that's something to be figured out later. That's not good. So if we play this, kind of just pops in there. And we can fix that in other ways pretty easily. I'm not going to worry about that for now. If we change the stroke color, does that change? Cool, it does change the color of that stuff. Okay, cool. Let's add some 3D lighting to this just so that we actually have that lighting. What happens? So stroke width is 0, which 0.01, 1, 5. Okay, so that's not good. That exaggerates the effect. I can't tell if it's like Z fighting or if it's something else that's going on there. If we were to decrease that alpha too, I wonder what happens there. Yeah, it definitely looks like it's some sort of Z fighting. That's going to have to be looked into. We can add some lighting, though, pretty easily real quickly. Oh, and I probably shouldn't have changed that stroke width because now it's still going to look weird. Yeah, so if we go back here, let's just change that back to 0.1. And let's work on some 3D lighting, which should be pretty easy. Quick question about text path rendering. How is it done here? For my own UI rendering library, I was having difficulties finding a good solution to render it on the GPU. Tried using MSDFs, but those need to be pre-generated beforehand, not ideal. Yeah, so if I was doing a game, I would just cache the different sizes to a texture and then just blit the texture. It's kind of a combination of things going on here because I actually need the path for the text rendering since I draw out the text like this. So what I'm doing is I'm actually using FreeType to parse out the path of the letters. And then I'm laying out the letters and everything using FreeType metrics, so font metrics and everything. If we look at font.h, or I guess fonts.h, this is basically what it looks like. We have a glyph vertex, which has just a position and a control point, and the control point is basically just a thing to tell you whether or not it's a curved object, and so control points are like the points of a Bezier curve. And then I have this glyph outline, which is basically just a list of contours. A contour is one line, so this inner line is a contour, this outer line is a contour, and you can kind of see that if we look at the O. It draws the outside, then it draws the inside. So there's two contours there. And then we have these metrics, so advance X, bearing Y, descent Y, which are just different like ways to lay out the text. So I use that for the outlines, but then what I use for the actual rendering is Nano VG. I'll eventually switch away from using this. And what Nano VG does is, let's turn this back on. I just realized that was off. Gotta turn this down a little bit though. Okay, and then what Nano VG does is this actually renders the font to a texture, and then it just blits that texture onto here. So if we scale this up a lot, it's actually gonna kind of decrease performance. So if I go here, you can see it's getting kind of laggy as I'm zooming it up, whereas like down here, smooth, not so smooth. And that's just because of the way Nano VG is doing things. I'm eventually gonna switch off of it and not use that at all because it slows things down. But yeah, And what they're doing is they're basically just blitting it to a texture dynamically. And you'll see they stop blitting it to texture once you get to a certain font size. So this works pretty good. And you get nice crisp edges because it's literally just rendering it at size. But for performance reasons, you probably don't want to do that, which is why I would either limit the font size or something else like that. But yeah, simple blitting to a texture though is usually more than enough, and you can do quite a bit with it, and it works out pretty good. And then this also, the way I'm doing it allows me to pretty easily just switch between different fonts because, so what you saw happen there too was that loaded the font, uploaded texture to the GPU, cached all the characters, all that stuff, all in that instant of a second, and it didn't cause any lag. So like this stuff is all fairly fast, and you don't have to worry too much about that. Yeah. Little guy, the UI looks like a combination of game engine and video editor. Is that timeline thingy custom, by the way? Timeline thingy is custom, and yeah, I guess it kind of, I'm going based off of like DaVinci Resolve, which is a video editor, and some video editors are nicer than others. If you've ever used, what's Adobe's? I think it's like Premiere Pro. I think that's absolute crap. So, yep. Sam, by the way, did you find out why the frame buffer had corrupted data? Sorry, I was already sleeping when you asked me on Discord. I did. And we actually saw that on the stream too. If we do, where was it? Because I triggered this just a little bit ago on the stream, and I'm trying to remember exactly what it was. But I think it's basically, if we take away this, oh, well, not that part. If we go to draw list, begin draw list 3D, no? Okay, yeah, begin draw list 3D. There you go. So if we go down here and I comment out this stuff where I explicitly say which draw buffers I am drawing to, it does that. And I'm not sure exactly why. I think what's happening is like OpenGL is clearing the two frame buffers at the same time that I'm trying to use them. Oh yeah, and so you can see it just completely breaks here now. Did I mess something else up? I think it's just because I have up here. Yeah, this. If we just change this to that, so that I'm actually drawing to all of them, it does weird stuff. Yeah, there we go. So we get that weird glitching, and I think what's happening is OpenGL is trying to use, because I'm using two of the frame buffer attachments, and I think it's trying to clear those at the same time that I'm using it, since I'm not explicitly saying don't draw to them, and then it does this weird glitching thing. RenderDoc still says it's fine though, and I'm guessing that's because RenderDoc fixes that somehow. In Harry Studios, so for fonts, it's a CPU render, right? Because I was looking for GPU solution only. I know Slug is a library, but it's not open source, unfortunately. Yes, and FreeType is completely CPU side. And I've looked quite a bit into like GPU rendering of Bezier curves and stuff, and it's just not worth it in my opinion. Like trying to get it to work accurately, there's all sorts of drawbacks and trade-offs and whatnot, and it doesn't meet all the different aspects that you would, especially for like smaller fonts and stuff. And that's just because of the nature of Bezier curves and how context dependent they are in order to draw it properly and stuff. So yeah, CPU render is perfectly fine. I spent a long time looking for GPU solutions, but they're really not necessary. You can use CPU and then upload to the GPU, and it's fast enough for pretty much all purposes. I don't think any modern game engines actually don't use CPU. I think they all use like a CPU thing, or like do offline rendering, like SDF fonts, that type of stuff. So yeah. But yeah, this is working pretty good. I'm gonna take a break very quickly, and then when I come back, what we'll do is we'll add some lighting so that the different faces of the cube at least have a different lighting, because this cube isn't rotating. We're rotating around the cube with the camera. So we'll do that. And then I think that's probably gonna be the end of the stream once we get that working too. So yeah, I will be right back, and we'll pick up where we left off in just a few minutes. All right, so the last thing we're gonna do is add some lighting for this cube, which should hopefully work with other 3D objects as well. And then I think that's about all we need. So in order to do lighting too, we need a couple different things. We need normal vectors, and then if we ever want to do some sort of textured stuff like normal textures, we would need tangent vectors, but those are part of those. So yeah, I think what we're gonna do is we're just gonna add like normals to our 3D vertices, and then we can add some 3D lighting. So in order to do that, let's go into here. So I believe we're gonna have to do this in both of these places. Yeah, this is one of the problems with the order independent transparency, is you kind of have to duplicate a lot of stuff in order to get it to work for opaque objects and transparent objects. So maybe I'll figure out a way to fix that at one point, but for now, this is the best we can do. So we'll take in a vec3, which is the normal, and then we'll put out a vec3, which is the normal. And then in here, we can just say a normal equals f normal. And we actually need, we should probably transform this. Okay, so we're not taking a transformation matrix, but that's something that we're probably gonna be adding in eventually, which is like model matrix. And then once we add that, we would add like this equals that times that, whatever, just so that we get like the transformations applied and all that too. I think that the mic audio is lagging behind the camera. It's very potential. Unfortunately, I don't think I have much control over that. I think I could probably change my stream settings. I might look into that. I might have changed, the streaming might be going at 60 FPS while the camera's going at 30 FPS, which would be audio desync. But yeah, I'll look into that after the stream. It might also just be lagging because of Twitch and stuff and whatever they're doing to encode audio and all that stuff. So, but thank you for letting me know. I will look into that after stream. Okay, for now though, so we have this, and then what we're gonna do is we're gonna take in a vec3 f normal. And what we also wanna do is have a uniform, which is going to be our sun position. Or I guess just our sun direction, because we just want a directional light. We don't actually want a positional light. Gabe, I just noticed a weird thing on Twitch. In the community tab, you can gift a sub to the broadcaster. That is strange. I mean, I guess if you want to gift a sub to themselves, like, I didn't know you could do that, but I guess if that's the way Twitch wants to do that, works for them. Let's also take in a vec4, which is the sun's color, and we're calling this the sun. I don't know, we could call it global illumination or something else, whatever. It's all the same stuff. Let's go open up my favorite Learn OpenGL website, and we're just gonna steal their lighting code, which is what I usually do whenever I want to add some simple lighting. So we can just go into the basic lighting. We're just gonna go to probably diffuse. And we're gonna modify it a little bit because we don't need anything super fancy. N.L, yeah, that's basically all you need. But I always forget. Or it's easier, I don't know, it's easier on stream just to copy some code than it is to actually think about what I'm doing. So, yeah. Okay, so we get the light normal, then we get the light direction, which is the light position minus the fragment position in that frag pose. They are getting from, where are they getting that from? That's just coming from, yeah. Okay, so that's the last thing we need to, is we need to say out vec3 f frag pose in vec3 f frag pose. So this would be the 3D position, I guess. And we can just do that. And that should be good. And then what we need to do is we just need to get the lights normal to that. So we have the light direction. This doesn't sound right. Light position minus frag position. That's the direction from the fragment to the light. That's not the light's direction. And then he's saying norm is normalize the normal. Sorry, I'm confused for a second. So he's saying that the light direction is the light position minus the fragment position, but that doesn't sound right. And then he's doing dot normal light direction. Sam, you said n dot l. Yeah, that is weird. The light direction should just be the light direction. Okay, whatever. So I'm wondering if this is even necessary. I think it is. I just think that's not the light direction. I think that's just the direction from the light to the fragment. And then diffuse is this, and then we just multiply by diffuse. Okay, we're gonna do this. So we do max dot norm light dir. Copied code is never compatible with your code base. I learned it the hard way. That is true. I have a base understanding, or at least I used to, of how this stuff works. So that's usually the most important part, is just understanding what's going on and stuff. But yeah. I'm wondering if we can just use the sun direction. I don't think we really need to do that fragment stuff, but I think we do, because we want to do, what is the norm? That's the normal of, yeah, okay. Light dir is what you said, Games with Gabe. Yeah, that's what I thought. It's the direction to the fragment pose. Yeah, it's like the vector between the fragment pose and the light source, not actually the light direction. So I think we should be able to just do this and we're fine. We don't actually need this fragment position, which is good enough for me. I mean, if we wanted to, yeah, no, that should be fine. Okay, cool. So we can do that and we can get rid of that. So we do that. Light color, which is in this case sun color, and they're using avec3. I guess we could do that as well. Diffuse equals diff times that, and then the diffuse we just add to the fragment color, I believe. Yeah, so we do the ambient plus the diffuse, and the ambient is just a constant, is what I think they do here. Yeah, I think it's just a constant, which is just like to add some base light. So what we can do is we can say float, wait, let's check that again. Ambient plus diffuse times object color. So we basically want to do the same thing. Ambient. Oh, and this should be, should diffuse be a vec3? Okay, I guess that should be a vec3. And why is ambient a vec3 then? That's kind of weird. Okay, whatever, but that's fine. So we can do that, and then we just want to clamp it so that we don't go below 0 or above 1. And then we can just do times that. Sam, yeah, just use the light direction uniform. You'll also need to normalize the normal from vertex since it will be interpolated and bigger than unit. Ah, that is true. So I guess we would say normalize F normal. I was gonna say, but it's already a normal, but yeah, you're right. Since it gets interpolated, I would not have thought of that until I saw it messing up for some reason. Okay, so ambient, what we're gonna say is vec3 ambient equals like 0.1, and I think that should be it. So basically we just add 0.1 at the base. So at least that. Okay, so now we just need to pass in a normal, sun direction, and sun color. Okay, so let's go into here. When we set up the 3D graphics buffer, right here, we want to add in, this is going to be 3 floats for our normal, vertex attribute 3, and then we will say this is the vertex normal. I guess we can just call it the normal because it's implied that it's a vertex since this is a vertex. Okay, and then if we go up to here, we can say vec3 normal. That should be good. And now when we add a cube, we're gonna have to add those normals as well, which should be fine. Add cube filled, F3. Okay, so right here, which is actually down here. Okay, here we go. Add cube fill. So this is what we want. So this is the... Ooh, okay, now, this is what always annoys me too. So now, all of a sudden, we can't use our indices the same way. So basically what I had was 8 unique vertices, and then we had the indices here. Can't do that anymore because now we have like different vertices for each face, which is always annoying. Why the heck does PyCharm require me to restart my computer? Another rootkit, I guess. Okay, so this is another fun thing about normals, I guess, is you have to duplicate vertices and stuff. Kind of. So... trying to think of what the best way to do this would be. We basically need to add each face, so that's 6 faces, that's 24 unique vertices, and then we can use indices from there. Okay, so let's add like the bottom face first, and then we'll add the left face, right face, all that stuff. Okay, so this is the fun stuff. Left face, I guess we'll do top face, left face, right face, back face, front face. Okay, so let's do this. So the bottom face is gonna be back, bottom, left, back, bottom, right, front, bottom, left, front, bottom, right. Okay, so that's the back face, that's fine. Then the top face is gonna be all of that except the top. Same thing here. Same thing here. And same thing here. Okay, the left face. We just want to make sure we're using the left stuff. So back, top, left. Front, top, left. Okay, and then we want... so back, top, left, front, top, left. Front, bottom, left. And then we want back, bottom, left. Okay, and then we want the same thing for the right face. We can just swap all those to right. That should be fine. Okay, and that should be good. Okay, then we need the back face. So just need to be back. So back, top, right. Back. Let's actually start with back, top, left. Back, top, right. And then we'll do back, bottom, right. Wait, this is the back face? Okay, yeah, I'm just making sure. And then back, bottom, left. Okay. And then the front face, we can just change all that to front. And we should be good there. We'll do that, and we can just get rid of all that stuff. So then we do front, top, left. Front, top, right. Front, bottom, right. And front, bottom, left. Okay, and these are all gonna follow the same pattern. 0, 1, 2, 0, 2, 3 for the triangle. So I'm not even gonna go ahead. We're not gonna do all this. We can just say for int I equals 0 until I is less than 6. I guess we'll call this face. Okay, so that's the faces, and then we want to add 6 indices for each face. I think I have something in here that's like index start. Okay, yeah. So we'll do index start. We'll say int face index equals index start plus face times 4. So we have 4 indices per face, 4 vertices, right? 1, 2, 3, 4. We'll do that. And then what we can say is indices.push. So this is the first triangle, face index plus 0, 1, 2. And then 0, 2, 3. Okay, and that should push all of our indices. Okay, so that should be it. We also need to do this, so vert to add dot normal. So since this is the bottom, we'll say That's 0. That, right? And then that should, since we're just copying it, use the same normal for each of those. Top face, we want that to be +1, not 11. Left face, we want that to be -x. Right face is a +x. Back face is a -z. In my Minecraft clone, I have X and Z swapped, which is the most annoying thing ever, and I'm never doing that again. X should always be right and left. Z should always be front and back. Don't ever swap it like I did, because you'll be in a world of pain if you do. It's annoying. Okay, so that should add all of our vertices there. Let's go ahead and modify this as well. We just want to make sure that this has location equals 3, a normal. Okay, I'm not actually going to add the code there yet, but this should all work out. We should still see a cube. So if I were to do this, nothing should change, hopefully. If it does, then we've broken something. So, assignment to varying, a normal. Okay, so I'll have to check out what that's about. Okay, so almost. It looks like I've got the top and the bottom triangles crisscrossed over themselves. So let's fix that very quickly. Let's also reduce that opacity so that we can see a little bit better what exactly is going on. Oh, and this is a good test too. So I was like so confused that we weren't getting like different transparent levels in the same object. This is a really good test. Since the triangles are crisscrossed, you'll notice it gets darker where the vertices overlap clearly, and it gets lighter where they're not. So order independent transparency is working to a T. We have that good, which is nice. Okay, let's fix that really quickly. The top and the bottom faces are crisscrossed. Why is that? Probably because I was stupid and did this wrong. So we have back, bottom, right. Okay, so we have back, bottom, left. We should go back, top, left. And then we'll go... Wait, no, we should not do that. Okay, so back, bottom, left. And we're doing the bottom. So then what we're gonna do is back, bottom, right. This should be front, bottom, right. Front, bottom, left. Okay, and let's swap that down here too, and that should fix the problem we were having. Okay, so now if we go back in here, we are good. Okay, cool. So now we have that. Let's increase the transparency and see if, because if we increase that to 1, oh, I guess I don't have it. Okay, so technically they're all going through that transparent shader. I don't have it actually sorting them between transparent and non-transparent objects, so we'll have to fix that eventually. But yeah, let's fix this up real quickly though. So we have that out vec3 f normal. Let's do this. Copy that, and then let's also go in vec3 f normal, and we're also gonna have to add a sun direction and stuff too. And that stuff. That's good. And then we want to do this whole thing. So if we do all this, we can say vec4 pre-multiplied color equals this stuff. Okay, and that is our pre-multiplied reflect. So this is basically just our, whatever. the color as it should be according to lighting. And then we apply all the order independent transparent stuff. Let's add these uniforms very quickly. So if we go down here, wherever we render this stuff, which is, actually, I think that was it. Render, yeah, right here. Cool. So we just want to upload those shader values as well. So we can say transparent shader dot upload vec3. I think I called this position. Is that what I called that? Sun direction and sun color. So direction is, we'll just hard code this for now. Yeah, we want a vec3 here. Something like that, minus 0.2, and then like minus 0.8. Sure, that works for me. Okay, and then we want a color. So the color will just be a white color. We'll do like that. right? That should be fine. We can change it to like an orangish hue in a little bit, but for now that should work. Is that what I called it? Use sun color? I did. Okay, so now we should have lighting. If it all works out, it should just magically work. No, I have shader errors. Okay, what's happening here? Assignment to varying a normal. Do I assign to a normal somewhere? Did I get this wrong? I did. This should be F normal equals a normal. I had that backwards. Okay. Fix that. And I never assigned that in here, did I? No. Okay, we do need that there. So let's see. What was the other? Implicit cast from Vec4 to Vec3, incompatible types. Okay, so sun direction, sun color. I think that's probably happening here. So diff times sun color. I do Vec3, okay. I think what I should be doing here is just that. And I mean, honestly, this should just be a Vec3. Let's just fix that. That's better. Okay, so same thing in here. Where did I put that? That's down here. Okay, Vec3. Get rid of that, and we're good. And now let's go ahead and stop that. And go back here. Just remove that, and we should be good. Okay, let's see if that works out. Should just magically work, hopefully. Sam, you need to rename the uniforms for sun. You did not add the U before the name. Did I not add U? I did not. You are correct. Thank you. I'll rename them in here because this is easier. Okay. Why is this not happy? Because I need to change that. That's better. Okay, so now it should just magically work. Okay, looks like we've still got shader errors. I shouldn't have gone there. Okay, assignment of incompatible types, Vec4 to Vec3. Am I still... Okay, so Vec3, Vec3, float, diff equals F normal, Vec3, sun direction, Vec3. Okay, we dot that. That should be a float. That's fine. Diff is a float. Sun color is a Vec3. That should be fine. Vec3. I think what I need to do is Vec4. I think that's what it's complaining about. Okay, let's try that out. There we go. No errors this time. Okay, cool. And we have... Cool. We have sunlight direction and stuff. So you can see it looks a little bit weird, but I guess that's because this is like a semi-transparent object, and so it's lighting up different faces of the cube differently. Does this look right? I think this looks right. Right? Yeah, if you're seeing through the cube and it has sun hitting it, I don't know, maybe this isn't completely correct. Yeah, this definitely is not completely correct on second thought, because if light's passing through the cube and hits the opposite end, it shouldn't be as dark as it is here. But that's a much harder problem to solve, is getting the appropriate light levels due to the amount of light going through it and stuff. I think that's what that transmission was probably for, that I removed a long time ago. Yeah, this thing. Modulate the net coverage for composition by the transmission. This does not affect the color channels of the transparent surface because that is taken into account and transmission modulates reflection. This model does not handle colored transmission, so it averages the colored channels. Yeah, okay, so I think in order to get the appropriate sunlight going through there, we'd have to change some more stuff to get that working right. Let's change it to an orangish hue and just see if that works out correctly. And if it does, I think that's good enough for me, and we can call it a day there. HTML color picker. Let's go, we'll pull that just a slight orange hue. And then if we go into here, should be able to do that, hex, and that should almost work. We just need to, will that work? No, because it's returning a vec4. Well, here, we can say this. Okay, so that's that. And then we can do this. I guess this is free right now, so go and get that, guys. Okay, so if we go and do this, and we do this, suncolor.or. Okay. Now if we go, we should have an orangish tint. Can't tell if that's an orangish tint. It looks basically the same. Gonna go ahead and say that it is an orangish hue. We'll amp it up a little bit, just make sure. If we go ahead and just choose something like that, that should be more obvious. Okay, yeah, so that's definitely changes the color. You can see it kind of getting more orangish here. Okay, cool. Well, I'm pretty happy with that. And then if we increase the alpha, shouldn't be transparent anymore. It's weird that we're still seeing through it there. Are we seeing through it? Wait a second. Yeah, we're still seeing through it. That's strange. Okay, well, I'm gonna have to look into that because, oh, I think it's just because I need to render this normally. I think that's probably the only problem with this. I shouldn't be submitting an opaque object through the transparent render and stuff, but I'm okay with this though. This is pretty good. Cool, well, that's some good progress. I wanted to get some 3D objects out of the way, and it works semi-okay with 3D lines, which is nice. If we change this to white, you can see the 3D lines there around it. Yeah, I'm pretty happy with that. It's turning out pretty good. And I just need to add some new animations and stuff, and then I think I'm gonna be able to use this to hopefully finish editing the next video finally. And then we can go from there, but yeah. Probably gonna end the stream in just a few minutes. Yep, gotta go right now. Been fun watching the stream. Thanks, Hilbert Curve. And yes, weird bugs. Okay, cool. Well, thank you guys for coming to the stream. Hopefully I'll see you guys next week. Possibly no stream next weekend, but we'll see. This is pretty good progress though. I'm happy with the way this is turning out. Awesome. Well, I will see you guys next time. Thank you for watching.